Hello and welcome to our presentation. This is for our project, Detecting Misleading News, project by Christian Ewer, myself, Nick Giordano, Donald McKay, and Nicholas Romeo. A little overview about our problem. False and misleading news articles are being shared more often throughout social groups and social media, such as Facebook, Twitter, etc. I'm sure that we have all seen articles on these social platforms that just don't seem right. These articles are meant to provoke certain emotions from readers without providing sufficient evidence or a factual basis. But we plan on solving this issue by analyzing various articles from a multitude of sources to gain the ability to detect which articles are misleading. And that's great, but why should I care? Well, these articles are a threat to the power that comes from knowledge. They affect many fields, including politics, health, entertainment, and so on. A more recent example of this includes a multitude of articles written regarding COVID-19 and the various vaccines. And while there are legitimate reasons for opting out of receiving any vaccine, misinformation has provoked fear and distrust in individuals who would have otherwise received the vaccination, thus worsening and prolonging the current pandemic we're facing. Models like these are already used by social platforms to warn users of their reliability before deciding whether to read a given article. A little bit about our approach. Very simple. We collected and prepared our data. This included collecting multiple data sets and combining them to form our training and testing data. After that, we trained multiple models. This included using natural language processing, support vector machine, and passive-aggressive classifier. And lastly, we analyzed our results. We compared the performance of each model to determine which one was the best. This included looking at the overall accuracy and also how long it took to train that model, since we are working with large amounts of data. Data collection and cleaning. So for our data collection, we used data sets from Kaggle and Princeton University. In addition to this, we also collected articles from various online sources. We combined 4 data sets on our own collection to use for training and testing our models. And then in total, we collected 23,485 unreliable articles and 12,256 reliable articles. So it was definitely unbalanced, and how we could have prevented that later on, but this was the data that we collected. So in terms of data cleaning, the data set from Princeton included partial fake COVID-19 articles. So they were only snippets of the first couple sentences. To complete this data set, we created a program to go to each website and or URL, which was in the data set itself, and gather the full article text. So after we gathered this information, we had to remove HTML tags and other information so that we only had the important bits. Another issue we ran into was caused by using multiple data sets. Each set had different attributes and needed to be trimmed to conform to a single set. This also included moving around some of the columns so that everything was consistent, with having just the body of the article and then whether or not it was reliable. And then unexpectedly, another issue we ran into was our data contained special characters that were being used as apostrophes and quotations. These characters' values were being read incorrectly and caused an error when trying to train our models, which was an invalid conversion from string to float. And so we were able to resolve this through additional cleaning of our data, but it definitely wasn't something that we were thinking about or looking out for when we did our initial cleaning. Analysis. So first up, we used natural language processing. This included using a library called Spatie, which is a pre-trained natural language processing model that's available to use in Python. So We trained Spacey on a 20th of our total data set and received great accuracy of 99.99%. In total, it took approximately 11 minutes and 27 seconds to run this model. That is why we only ran it on a 20th of our total data, due to how long it took to train. And because, again, of how long it took, we decided to try other models to see if we could find something better. So next up, we have support vector machines. Support vector machines are used as another popular algorithm. SVMs support both classification and regression. In our case, we used classification. And when training this algorithm, we received an accuracy of 99.27%. So to train and test this model on our full data set, took a total of 14 minutes and 47 seconds. So while the accuracy was a little bit lower than natural language processing with Spacey, the total time it took was significantly lower. And then last but not least, have passive-aggressive classifiers. Passive-aggressive classifiers are online learning algorithms that are used for large-scale learning. The classifier is trained incrementally by passing in data individually or in small batches. They are great for using with data streams. So if you're using a Twitter API and receiving tweets, you can feed that right into a passive-aggressive classifier, and it'll very quickly give you results and can handle large amounts of data all at once. This model is passive when correct and aggressively adjusts when it is wrong, hence its name. And when training this model on our full data set, we received an accuracy of 99.538%. And training and testing this model took an impressive 16 seconds total, which was significantly faster than the other two. And our accuracy of this was actually better than the support vector machine, and took a lot less time. So overall, we decided to run with the passive-aggressive classifier due to its overall speed and accuracy, like I had mentioned. Now, the passive-aggressive classifier has the functionality to set a specific penalty for when it is wrong and to set a maximum number of iterations through the data. So when adjusting these values from the default, a penalty of 0.5 and max iterations of 10 gave us a slightly better accuracy of 99.58%. And so we can see the confusion matrix in the classification report and the overall test set accuracy in the picture. So after running through all our data, we decided to make this little chart. So as you can see, these are fake articles from a given source with more than one match. We decided to only list the websites that had more than one fake news article in our data set. There were many more, but to kind of condense things, we only did with websites with two or more. So at the top, we can see factcheck.afp.com with about 280 fake news articles. And then close to the top, we also have Twitter and Facebook. As I mentioned earlier on, fake news articles are being shared all the time on these platforms, and that is where they're able to get their reach, and why they are so popular. And so you can see Facebook and Twitter, two of the more bigger offenders. Lessons learned. One of the biggest improvements we could have made in our project was creating a more balanced data set to train our models with. That would have given us a better sense of our true accuracy. And our current data set has almost twice the number of unreliable articles compared to our reliable articles. Now, we could have solved this issue by collecting more data through Google's API, or even articles shared on Twitter or other social platforms to add to our data set. and offset that big difference. But overall, our biggest lesson learned throughout this project was having the opportunity to combine all the concepts we learned throughout the summer in Data Mining 1 and 2 into a single project. So this really helped to solidify our understanding and confidence in the material, and really just get that practical experience that you don't get as much from the homeworks, where you're given the data set and a lot of different code. And last but not least, our sources. So this is where we got our data sets from. And that's it. If we were in person, I would ask if anyone had questions, but have a good one. Thank you.